Section 4.8 is all about isosceles and equilateral triangles. So let's first define or revisit what isosceles triangles are. An isosceles triangle has at least two congruent sides. When an isosceles triangle has exactly two congruent sides, the two congruent sides are called the legs. The third non-congruent side is called the base. And the two angles that are adjacent to the base, meaning the two angles that are touching the base, those are called the base angles. So looking at our diagram, this would be a leg since it's one of the congruent sides. This is also a leg because it's one of the congruent sides. This is the base. And then these two angles are the base angles. So this is a base angle. And this is a base angle. I would write this down in your notes with the diagram and how you can identify all the different types, the legs, the base, and the base angles. Now we come to two theorems. The first one is theorem 4.7, the base angles theorem. It states if two sides of a triangle are congruent. So basically it's saying if you have an isosceles triangle, because if it says two sides of a triangle are congruent, meaning you have an isosceles triangle, then the angles opposite them are congruent. The angles opposite the congruent sides, those are the base angles. So therefore, this is called the base angles theorem. So if I know that BA is congruent to CA, then I know that angle B is congruent to angle C. Then we come to theorem 4.8, the converse of the base angles theorem. It says if two angles of a triangle are congruent, then the sides opposite them are congruent. So basically this is saying if I know that these two angles are congruent, if B is congruent to C, then I know that AB is congruent to AC. So basically this is saying that if I know that these two angles are congruent, then I have an isosceles triangle. I would write these down in your notes as well. So let's look at our first example, number 1. We are given the diagram and we're asked, if segment HG is congruent to HK, then angle what is congruent to angle what? So if we look at this, let's mark on it first. So if HG is congruent to HK, that would make this triangle isosceles, meaning if these two sides are congruent, then the two base angles are congruent. So the two angles that are opposite the two congruent sides are congruent. So I can call this angle just angle G since there is only one angle sharing that vertex. But I cannot call this angle just K since there's more than one angle with a vertex of K. So this is going to be HKG. So we use the base angles theorem to solve that one. Part B says if angle KHJ is congruent to angle KJH, then blank is congruent to blank. Since there's no angle symbol, I'm going to assume that we're going to talk about segments for this one. So again, let's mark on our diagram. So KHJ is this angle right here, and KJH, which is this angle right here. So these are the base angles of this isosceles triangle right here. And I know this is isosceles since the base angles are congruent. So the sides opposite them will be congruent. So opposite this angle J is this side right here, and opposite the other angle is this side right here. So that means that HK is congruent to JK. And to know that, I was actually using the converse of the base angles theorem. Example number 2, find the measures of angles X and Z. So if you look at the diagram, we are first given that XY and ZY are congruent, and we know that angle Y is 50 degrees. If these two sides are congruent, meaning I have an isosceles triangle, then according to the base angles theorem, I know that the angles opposite them, or the base angles, are congruent. So I'll mark that on my diagram. I know that angle Y is 50 degrees. I also know that these two angles are congruent. There are a total of 180 degrees in a triangle. So if I take 180 degrees minus 50 degrees, I get 130. That means that these two angles have to add up to 130 degrees. But we know that angle X is congruent to angle Z. So if they both have to add up to 130 degrees and they're both congruent, I would just take the 130 and divide it by 2 to find the measure of each individual angle. So I would get 65 degrees. Therefore, the measure of angle X is 65 degrees, and the measure of angle Z is 65 degrees. If you weren't sure you did that correctly, just take 65 degrees here plus 65 degrees here and add it to the 50 degrees and make sure you get that 180 degrees, which you do. Example number 3, find the lengths of segments ST and SU. Notice that we are given that all 3 angles are the same and the length of TU is 5 units long. Let's use the converse of the base angles theorem to figure some stuff out here. So let's look at these two first. If S is congruent to T, that means the sides opposite them are congruent. So that means that SU is congruent to TU. If you look at these two base angles, if these two base angles are congruent, then the sides opposite them are congruent. So that really just means that all 3 sides are congruent. If all 3 angles are congruent, then all 3 sides are congruent. So basically we have an equilateral and an equal angular triangle. So if TU is 5 units, then ST will be 5 units long, and SU would be 5 units long. Recognizing that if you have an equilateral triangle, you also have an equal angular triangle, and vice versa, from this problem leads us into our next theorems on the next slide. So you can see here we have corollaries. We've talked about corollaries before. A corollary is another theorem that is a direct result from the original theorem. So the first one we have is the corollary to the base angles theorem. So it states that if you have an equilateral triangle, then you have an equal angular triangle. We have the corollary to the converse of the base angles theorem, that if you have an equal angular triangle, then you have an equilateral triangle. So here's a question that I pose. Can any equilateral triangle have an angle of 60 degrees? So if I have equilateral, that means all 3 sides are the same. Now we also know that if all 3 sides are the same, all 3 angles are the same. If all 3 angles are the same, and all 3 angles need to add up to 180 degrees, if I take 180 degrees divided by 3, I get 60. Therefore, each angle in an equilateral triangle, or in this case an equal angular triangle, has to equal 60 degrees. Therefore, you could not have an angle of 61 degrees. In any equilateral or equiangular triangle, you will always have angle measures of 60 degrees for all 3 angles. I would write that down on my notes. Example number 4. Find the values of x and y in the diagram. So if you look at the diagram to begin with, I see this triangle right here. I see that all 3 angles are the same. If all 3 angles are the same, then all 3 sides are the same. So if this side is 7, and it is congruent to this side, then x equals 7. Now on to finding y. So look at this triangle. You see that this angle is congruent to this angle. That means the sides opposite them are going to be congruent. So that means that this side is congruent to this side. So we learned earlier that this side is 7 since all 3 sides over in this triangle are 7 units long. So if this is 7 units right here, then y plus 4 would have to equal 7. So therefore, y equals 3. So there's my 2 answers, x equals 7 and y equals 3. Next, it asks, find the measure of the only unmarked angle in the diagram above. That would be this angle right here. So let's go back to this triangle. We know that it is equiangular and therefore also equilateral. We just saw in the last slide that in any equilateral / equiangular triangle, all angle measures are 60 degrees. So if this is 60 degrees right here, and it is forming a straight line with this unmarked angle right here, and I know the measure of a straight line is 180 degrees, then to find that unmarked angle, I would just take 180 degrees minus 60 degrees to get 120. So that unmarked angle would be 120 degrees. And even though it is not asked, if this is 120 degrees right here, I know that these 2 angles have to be congruent. So if this is 120 degrees and there's 180 degrees in the triangle, then these 2 angles would have to add up to 60 degrees. And since they are congruent, that means that I would just divide by 2, so each of these angles would be 30 degrees. And here we have our last example, number 5. Find x and y in the diagram. So let's just take a look at what we are given. We are given that this side is congruent to this side. So that means that this angle is congruent to this angle. We are given that all three sides in this triangle are congruent. So therefore, it's equilateral, so it's going to be equiangular. So I'm marking it as I go. If this triangle is equiangular, that means that each angle is 60 degrees. So that means also that x is 60 degrees. I'm also told that this angle right here is 90 degrees. So if this is 60 degrees, I can find this angle measure by taking 90 minus 60. So this smaller angle right here is 30 degrees. If that's 30 degrees, then this other angle that it's congruent to is 30 degrees. So I have 180 degrees in a triangle right here. So if this is 30 and that's 30, that's 60 altogether. So to find the measure of angle y here, I would take 180 minus the 230, so 60, to get 120, and that would be what y is equal to. So x equals 60, y equals 120. That's it for this section. Make sure you jot down anything you don't understand, and make sure you write down everything I said. I would definitely write down in your notes, and we'll cover everything that you didn't understand in class, and we'll see you then.